Okay. Okay, the first law that we're going to be seeing is John Dalton's law of partial pressures, okay? Which said that the pressure of each gas in a mixture of gases is called the partial pressure of that gas. Dalton's law of partial pressure states that the total pressure of a gas mixture is the sum of the partial pressures of the component gases. So, this law is going to be expressed, as you can see, that says the total pressure, okay, the total pressure PT is equal to pressure 1 plus pressure 2 plus pressure 3, etc. Which means that the total, by definition, okay, the total pressure is the sum of the partial pressures of the gases. If I have 5 gases, I'm going to add the partial pressures of the 5 gases. And the addition of the 5 gases is going to give me the total pressure. I mean, the idea is quite simple, okay? Each pressure is going to have its individual partial pressure, okay? And when you add them all, you're going to have a total pressure. Now, for that, let's see this sample problem. It says oxygen gas from the decomposition of potassium chlorate was collected by water displacement. The barometric pressure and the temperature during this experiment were 731 torr and 20 degrees Celsius, respectively. What was the partial pressure of the oxygen collected? Okay, first, what we need to see is what the problem is about. Okay, so we're talking about a reaction of the decomposition of potassium chlorate. Okay, now it says that the barometric pressure during the experiment was 731 torr and the temperature was 20 degrees. So in here you see a table that says water vapor pressure. Okay, so we're gonna focus on the part that says, take a look, it says it says oxygen gas chalala chalala was collected by water displacement. That's why we're gonna be using this table that is called water vapor pressure. Okay, now what do we need to know? They are giving me a temperature of 20 degrees. Okay, with this 20 degrees we're gonna be able to use this table. Okay, so this 20 degrees, you're going to look for 20 degrees in that table, which is right here. Okay, and from this you're going to get information. You can see that this table gives you temperature, pressure in millimeters of mercury, and pressure in kilopascals. Which one are you going to use? It depends on the units that you have. In this case, they are giving you torr. Okay, remember that torr and millimeters of mercury, they are equivalent. That is that 1 millimeter of mercury is equal to 1 torr. This is an equivalence, okay? And because this is an equivalence, we are going to say that these torr are actually millimeters of mercury as well. Okay, so what part of the table are you going to be using? You're going to be using the part that says millimeters of mercury, okay? Because that's the unit that the problem is giving you. If, for example, it gives you pascals, you're going to be able to convert from pascals to kilopascals, and you we'll be using the part that says kilopascals. This is not the case. I'm just telling you what if. Okay? Now, from the table we obtain, what value are we going to use? 17.5 or 2.34 then? 17.5. Okay. So, we're going to focus on the unit that is given to us, which are torrs or millimeters of mercury. So we're going to be using the pressure of water vapor to be 17.5 millimeters of mercury. Now, it says, what was the partial pressure of the oxygen collected? According to Dalton's law of partial pressures, we have this formula. The total pressure of the mixture of gases is equal to pressure of the gas 1 plus pressure of the gas 2 plus pressure of the gas 3, etc. That is the main equation. Now, how many gases are acting in this problem? Let's see. Ay, no, qué ruido. Okay, we have oxygen gas. This is the first gas that is mentioned in the problem. What other gas is mentioned in the problem? Okay. When it says was collected by water displacement, when it says like that, by water displacement or collected over water, we are talking about water vapor. And as you remember, water vapor is a gas. Okay? So how many gases I have in the problem? How many gases I have in the problem? I have oxygen gas and I have water vapor. So I have a total of 2 gases. Okay? And I have the total, the barometric pressure, okay, of the mixture. So, for this exercise, I just have 2 gases that are the first one, that is the pressure of oxygen gas, and the other, that is the pressure of water vapor. The one of the water vapor is the one that we used and that we get from the table, which is this one, okay? And the pressure of the oxygen gas is what we need to find. Why? Because it says, what was the partial pressure of the oxygen collected? So I need to find this one, the pressure of my oxygen gas. And the total pressure is what the problem is giving me as the barometric pressure, which is equal to 731 millimeters of, okay, these are torr, but they are also millimeters of mercury. Remember that we need to keep the units in the same conversion factor, okay? Now, I'm going to make substitutions, and of course I will isolate for my oxygen. So, the pressure of my oxygen, therefore, is going to be equal to okay, water vapor here is adding, so when you move it to the other side of the equation, it's going to be subtracting. Okay, so you're going to have 731 millimeters of mercury minus the pressure of the water vapor at 20 degrees Celsius, because it's the temperature the problem is giving me. So minus 17.5. Here you don't read the units, but the units are here in the top, okay? These are millimeters of mercury. So you just need to subtract. You're just gonna need to subtract What is the total? 713.5. What is the problem ask you to find the partial pressure of oxygen, but in pascals? So you will have to convert, okay? So always read what the problem is asking you. In this case, in the question, it doesn't mention what units you need to give, okay? So you can leave your answer in millimeters of mercury or torr, because torr is the unit that is used in the problem. But you know that they are the same, basically. They are equivalent. So, but if the problem says what was the partial pressure in ATM or whatever unit, you have to be respectful of that, and you will need to convert. I don't know if about this problem you have a doubt. It's quite simple. Well, let's continue with the other problem. It says a sample of nitrogen gas is collected over water. What does collected over water mean? Okay, that is another gas that is not mentioned and is water vapor. Okay. Okay. At a temperature of 25 degrees Celsius, what is the pressure of the nitrogen gas if atmospheric pressure is 789 millimeters of mercury? So what are we going to do in this problem? What are the gases that are mentioned in the problem? They didn't mention, but they said collected over water, which is water vapor. What is the other gas? The other gas is the first one mentioned in the problem, that is nitrogen gas. Okay, so here they're asking me what is the pressure of nitrogen gas, and they're giving me the atmospheric pressure. The atmospheric pressure, that means the total pressure, okay, of the mixture. Okay, the atmospheric pressure is 789 millimeters of mercury. So we need to find what is the partial pressure. So let's see. Total pressure is going to be equal then to the pressure of nitrogen plus the pressure of water vapor. Okay? Now, do I know the pressure of water vapor? Do I know the pressure of water vapor? No, I don't have it, but it's in the table. They're giving me a temperature. So I go back and look for the table, and I will look for the temperature of 25. Okay, the problem is giving me a temperature of 25, so I go and see the table, specifically in the temperature of 25, which is right here. Now, which one I'm going to use? The pressure in millimeters of mercury or in kilopascals? To see that, I need to see the units in the problem. They are giving me millimeters of mercury, so I will focus on the part that says millimeters of mercury, which means 23.1. Okay? So we see millimeters of mercury, and that is 23.1. And we make substitution in our problem. Oh my god, yes. Sorry, I'm blind. Thank you. The one of 25. That is actually 23.8. I was about to make the mistake. Thank you. So 23.8. So in our problem, in our procedure, we're going to make substitution by 23.8. Okay, water vapor is 23.8 millimeters of mercury plus the pressure of nitrogen equals the total pressure, that is going to be 789 millimeters of mercury. I'm going to isolate this one, okay? So the pressure of nitrogen then is going to be equal to 789 millimeters of mercury. And what do I do with water? I add or I subtract? I subtract 23.8 millimeters of mercury. So you can see this topic is so easy. The only complexity that it could have is that I give you like different units and that you have to convert. But the idea of the problem is quite simple. How much you got? Okay, 65.2 millimeters of mercury is equal to the pressure of my nitrogen gas. Okay, that's it for the partial pressure. I don't think I need to explain more than that. And the next topics that are coming are the same simplicity. So for that, I'm going to share with you the link of a video that you have to start watching. Or I don't know if you want me to project it. No, we're gonna do like that because I have no way to know if you actually watch it. So I'm going to send you the link, and if I text you a message, you should send me a screenshot that you are watching the video, okay? So if you receive a message from me, you will send me a screenshot that you are actually watching the video. There is the link. In that link, I explain Boyle's and Charles' law of gases. Okay? You can start watching now. Be attentive of your chat. If you receive a message, you have to send me a screenshot.